Hello and welcome to this walkthrough of a multiple choice question which requires you to work out gas moles at room temperature and pressure using the idea of limiting reagent. So it tells you that 8 decimeters cubed of NO is mixed with 6 decimeters cubed of O2 at room temperature and pressure. That instantly should say that you're dealing with a V equals 24N type calculation. So the first thing is to work out how many moles of each gas you have to start with, and using V equals 24N you get 0.333 moles of NO and 0.250 moles of oxygen. Then it says the reaction takes place until one of the reactants is used up, so that suggests there's a limiting reagent involved. So you need to work out which reactant gets used up first. Is it nitrogen monoxide or oxygen? So looking at the balanced equation, the number of moles of NO to the number of moles of NO2, number of moles of NO to the number of moles of O2, I should say, is 2 to 1. So 0.333 moles of NO will require 0.1665 moles of O2. This means that the O2 is in excess because there's greater than that number of moles available. You can see quite clearly we've already worked out that there's 0.0250 moles of oxygen available. So then they want the volume of the mixture at room temperature and pressure after the reaction has taken place. So you need to work out how much of the excess reactant is left and add this to the product formed before converting the total moles back to volume. So 0.250 moles of O2 will react fully with 0.333 moles of NO to make 0.333 moles of NO2 according to the nitrogen monoxide to nitrogen dioxide mole ratio being 1 to 1. So at the same time, if you subtract the 0.1665 moles of oxygen that were used up from the original 0.250, you've got 0.0835 moles left. So the total moles of gas remaining is the 0.0835 plus the 0.333 moles of NO2 that you've just made. So that gives us a total of 0.4165. And going back to V equals 24N, you multiply that number of moles by 24 to get 9.996 decimeters cubed. That's obviously going to be B as your answer. Okay, thanks for listening. Until next time, see you soon.